Hello guys. My name is Victor, as I was introduced, and I'm going to present you some Lightning talk. And all Lightning talks are like very stressful, like you having a piano over your head. So let's start right away. And I want you to introduce the new language, new Elm, which will fully change your understanding of how you should write your applications. So we had a problem with our application, which was started in 2015, and it was written back then in AngularJS, like version 1.5 something. And we had a lot of components, and we need to stick to support up to iOS 9. So, for example, we can't use CSS sticky and all other fancy things without any polyfills. So back then, we did a lot of errors in our application when we were developing it. So we were very big fans of services in Angular. We wrote there like tons of them, like dozens. But we didn't like directives. We had only 5 of them. And we very liked languages. So we wrote our application all in the same place with TypeScript. Some places were written in CoffeeScript. But like half a year ago, we removed CoffeeScript because it's not anymore actual. And in some places, we even had to write in vanilla.js because the performance of Angular wasn't enough for us. And we didn't have enough of unit tests because it's hard to write a unit test when every another module has a new language for it. And all this came into so-called effect of Uncle Fedor writes a letter to his parents. I know all you know this picture, and maybe some of you even had this situation when you have one developer, he comes to your project and says, hey, we need reactivity, let's have Kefir.js. Then another project with some mustache comes and says, hey, without types I can't proceed, let's have TypeScript. And then another developer who is not patient enough says, hey, it's too slow because you have so many types. Let's mute them all and have like just any everywhere. And then you go to code review and you don't know how to review it because there are so many things. And that was very pity. And this particular example, we had the vanilla.js inside TypeScript to improve our performance. And you can imagine how interesting it is to write a unit test for this or do a code review meaningfully. So all this went into a situation when we needed to have hotfixes. And it's OK. Every application needs to have a hotfix. So we find an error, and we make a fix for it. But then the back pressure appears, and you have 2 more bug fixes needed to be done. So it wasn't very good. So we wanted to search for some silver bullet. And back then, it was in the beginning of this year, we had choice of React, Vue, and Angular without JS. They finally cut out the JavaScript part of it. So why we choose Elm, not these top 3 solutions? So React is boring because we already had some neighbor project which was working very well and fast, and we knew that we will achieve our results with React. It was not very interesting. We didn't want to try Vue because the syntax of it reminded us the AngularJS, and it was a pain for us, just the syntax. And Angular without JS we didn't try because of the ladder effect. So between these 2 models there are like 30 years of development, and they didn't change a lot. And we knew that with cutting JavaScript they changed a lot, but we didn't believe it. So why we chose Elm? It's a lightning talk. We don't usually raise hands, but one time I want to ask you, who knew about Elm before this presentation? Who? OK, remain your hands. And who tried it? OK, great. So other people should try it after this talk because it's lightning. It should light interest in you. So all these things will be covered further. So Elm was first made in 2012 by a person named Evan. I can't pronounce his surname, sorry. And it's very functional. It's functional from the roots of the language. And it's immutable, and it has static typization, and it has models, so you don't need to write all your code in one file. You can spread around files, very nice feature. And you still communicate with your other frameworks on your page through the so-called ports. So let's write a Hello World application, and it's very easy. So in the beginning, as in C++ times, we say main, and then we say type that it returns something, and then we say, hey, we need text node with word hello world. That's so simple. And if we remove literal imports by the name, we need to write everything like from the model by dot. So this text, if you run it in your browser, will just show you hello world. And let's add some color to it. So what you're going to do is you search through documentation, you see that there is attributes like sub-library of HTML library, and it has method style. Actually, it's a function. Everything is a function here. And you pass there a tuple. And you expect everything to work, but you have an error. Why? Why it's so? But the reason is that HTML.attributes is a separate name. It's not a subset. So model names here can have a dot. So when you're making the structure of your project and you want it to replicate the folder structure, you need manually to add dots where you need them to have. So just a small piece which will be very annoying at the beginning, but more annoying things later. So if you want your code to look simpler, you can do like implicit import of every function you will use. So easy, then your code is very simple. And the whole structure of Elm application is like that, so-called T. Everyone likes T, green T in particular. So we have view, which can have some messages. Messages go into some core, and then they call update function, and then side effects happen, and then you have a model, which goes to view, and the circle is finished. So if you don't like this, there was created a special picture which shows you the same thing, but in other words. So you have a model, and this piece of white sheet is kind of your browser. So you, with messages, try to control how everything happens, and the update function does everything for you. Very simple. And you can say that, hey, I know React, and actually it's same thing as with React plus Redux architecture. So you see the same circle, the same messages go everywhere. And you can say, maybe like somebody has stolen from somebody something. And actually you are right. So in 2015, when Redux was made, Dan Abramov tweeted sometimes that he actually was inspired by Elm. So Elm was the first in this way. And if you know Redux, you can like make this assumption that model from Elm is state in Redux, message is action, and update as reducer. And knowing this and knowing the Redux, it's very simple to work in Elm. So congratulations, but that's not it. No, Sid. We still need to cover some more things because at Lightning Talk, I don't see a lot of interest in you to try Elm. So benchmark, why is it fast? So there is a well-known to-do application benchmark which runs adding 100 to-do applications once again. So it adds 100 to-do tasks and removes them, and then the measurements are taken. So it's kind of old, like 2 years old, but the thing is the same. So this like right part is unoptimized version. So you write as you know. And left part is when you do some performance tricks, like you add keys and you add indexes, and in Elm you also can do some performance tweaks. But anyway, Elm application is very fast. It's like a couple % faster than React and a lot faster than Angular first version. So let's think about types, because everyone likes types, but we don't like to say what will be your type. So let's imagine we will improve our application and we want to define which color, which text will be set. So we can create a function view and then the phrase in the argument, very simple. But now let's add a possibility to change the color. And we say that color is argument and then it passes down, very simple. And one time, by mistake or I don't know why, you will accidentally say 1. So if it would be under JavaScript, you will have what you will have. You will have color 1, and probably it will be something like blackish style. But in Elm, even though we didn't write any types there, we will have compilation error, not runtime error, but compilation time. And it will say you straight away, oh, nice feature, we will use it a lot. It expected string, but you have sent a number to it. And I want to emphasize that it's very neat because you didn't say that second argument will be type of string or number. Elm understood it itself. And also, it's very functional. It's very easy to have a particular applied function here. So here, subview actually is not a function. It's a partially applied function of view. So when you send to it one more argument, then only then it calls the next function. So a lot of errors, you're totally confused, but this is a very nice feature unless you see a function and you don't know, is it a function or it's partially applied? You can't say before like what kind of it. But it's very good for creating small like helper functions and your code looks very big. So you say, hey, I know functional approach, I use Lodash a lot, I use Lambda, and like I never mutated objects, so you think Elm will be easy for me. But unfortunately, Elm is not an approach. Elm is a new language with all new syntax which you need to learn. So for example, concatenation of strings is 2 classes. And you can't omit the else statement in your conditions because it's functional, everything should be determined. And for example, you can have you can divide with integers. So if you accidentally, or I don't know why, you will put 2 slashes, 9 by 2 will be 4. But sometimes maybe you need this. So it's new language, not an approach. And this is a real example of code which we use. And if you're a new developer into our project, usually people just escape from the room when they see this piece of code. But by time, you will eventually understand what's happening here. And one more thing which Elm has, and I think there can be no any application without this is null or maybe some undeterminate. So let's imagine we have a list of colors, and we want to say the color is the first element. So that's pretty simple. You write this code, and you expect it to work. But right away, you execute it, you will have this. And why this happened? So the idea is that head operation, like taking first element from a list, is not determined. You can have 0 elements in your list. That's why it returns maybe something. And to prevent these maybe things, we have method maybe with default. So you should pass this maybe thing to with default method and say something which will be default. So every case should be determined. Remember our if-else statement where you can't omit the else thing. So you have this, and we should welcome our new operator with pipe and angle bracket. This is a forward application, forward function application thing, and what it allows you to like rotate your function and argument other way. Sometimes it's helpful, and they say this can avoid having too many brackets. So let's try it. We have the very last line, which has a lot of brackets, like 2 brackets. We don't like them, and let's convert them using this operator. So you see, now we don't have brackets, we have only 2 other symbols. That's very cool. And these 2 things are actually equal, Like they produce the same result, so you should decide for yourself what you like more. And actually, Elm has a lot of operators which look a bit strange for the people who didn't see the so-called ML languages. And you can think that this is an Elm program, but unfortunately not. It's a brain fuck. I shouldn't say. Brain f dot dot ck app printing some word. And you can ask like who was the first, and I think the second language was the first. So let's try use these operators and remove all the dots and write everything in Elm style. So we just rotate everything to other side, and sometimes it looks like chaining things in JavaScript. And this is really logical. You have your input, your main object, and then you make some changes to it. And these two things are also equal. Later, when you will see the slides, you can read them more properly, and you can understand that they do the same thing, but with with different approaches. And we can even have third example of this, like the bottom one, which also does the same as two previous, but in more fancy way. So also you can communicate with your applications. That's very simple. You have just your port method, which is exported from any application embedded with Elm, and you can send any messages to it. So if you have something which is not implemented in Elm, implemented in your main, like mother framework, you can send it to Elm, and vice versa. That's very simple. I don't want to spend much time to it. And of course, you can use Elm inside your application using Webpack. It's very easy. Just you can say, will it be there any debug information or not? And if you say true, you will have kind of Redux web tools. Also, you can test Elm very easily. And the structure is kind of same like your mock or Jasmine test, so nothing to spend a lot of time. And they're very fast. Like 400 tests are taken like 2 seconds on very slow machine. And since we have types, we don't need to cover all the examples in your application. So for example, if you have like calculation application, which just summarize two things and then returns true or false, you don't need to check what happens if you pass not an integer but a string, because types won't allow you to do this. So you will save a lot of time writing tests covering only your business logic. And one thing which I want to show you that's very interesting, and not every language has it, and not so many frameworks have, is fuzzy testing. So imagine we have a function which just reverses our list. And we just write a test which tests this reverse thing. And you see in this test we didn't have any like fake data. We don't say which actual inputs will be. We just say use it with fuzz testing for list, and the arguments are integers. And this test works, and it even had 4 runs. But let's try to break it. Let's, instead of sorting, instead of reversing, let's sort the list, the input list, and right away our test will fail, even though this sample data was provided by Fuzz lib, not by us. And this is very useful to find edge cases, corner cases for your helper methods. So let's write the full application like MVC thing. You have your main application, like in C, you put it into HTML index, and then you should define a model. Let's say we have application, you click one, and it's like iterates your things. So model will be 0, and type of model is integer. Then you need to have HTML, and this is like plus minus things, very easy. And then you have kind of actions in the Redux, and you say that we have increment and decrement thing. And once message is increment, you will increment, and decrement will remove 1. Very easy. And then you put everything together, and you have an application which does what you see. So now let's improve it and try to have button with reset. And when you click reset, before you click reset, once you have a compilation thing, you will have this error which will say you called an action which doesn't exist. So let's add this action, and for now, let's say it's something which we don't care about. But once again, we have an error which will say you passed a string, but it should be an integer. So type detection is very neat, and the error messages are very nice to understand where the problem is. Once we fix everything, the reset will start to work. And there is one more thing which you should definitely look around, is making your state, making impossible state impossible. Usually we do this by our logic, like finding corner cases, but in real type applications, you can use these with types. So there is a link, you should definitely look for it. And my review of Elm is difficult, but only for your HR, because you can't find any developer. It's slow, but only during development. It will run in browser like instant. And it's reliable everywhere. Once you write something with Elm, it will not be overwritten anymore. And you should try it. There is Ellie app which you should use. And thank you.
So thank you very much.
Okay.
We have a couple minutes for our small
Still,
interview.
okay.
Yes. How many projects, how many Elm projects you have already done?
If not counting pet projects, it's one. But I want to emphasize that project we are working at is one of the biggest in Elm community. It has like around 50,000 of lines of code, like efficient lines of code. So the biggest one, which is known, is kind of like 100,000. So we are like fifth maybe in the Elm community, rather big, and sometimes guys from Elm do fixes which for bugs which we find.
I heard about Elm before, but I never tried it, so thank you, I will try it. We heard lots of good things about Elm, and maybe you can tell us some painful things about it.
The most painful thing, it's very hard, it's very unusual to what you used to write. The way how functions are created is partially applied functions, which are, you never know, is it a function which gives you the result, or if this function will give you another function. So sometimes it's very hard to determine. Also, it's very hard to find a ready Elm developer. Usually, these are just experienced guys who like to try new, and they're not afraid of trying some new. But overall, the Elm is a good thing to start, and if you will find some colleague who is fluent in functional approaches, and he will help you with writing these all roads and tunnels things, I think you will like it. And the best thing with Elm is that it has very small bundle size. So like HelloWorld application will have like 8 kilobytes maybe. So the overhead is like 8 kilobytes for the smallest application. In React, it will be like maybe 20, maybe, I don't know. And you can start by creating small applications, small parts of your application with Elm, and then you can grow this amount by time.
Thank you very much.
Thank you.